Our next speaker probably needs no introduction to most of you. Dr. Paul Yeske is a swine veterinarian with the Swine Vet Center here in southern Minnesota, and he enjoys working on disease elimination projects. His talk today is sponsored by the National Pork Board. Welcome, Paul.
Well, hopefully we can keep the technology working here this morning and be able to continue to go forward here. So we'll go ahead and go through the overview here a little bit. And basically what I want to talk about is just to review a little bit of the mycoplasma control all the way back to stabilization to elimination, some of the motivations and some of the methods we've used along the way, what's the future look like, and the question, why aren't we there yet? And again, this isn't work by myself, it's from the entire group of the Swine Vet Center aiding along and helping with the producers. And we know that mycoplasma continues to be an important pathogen in the industry, and not only, and Caesar's work showing us that it's an issue worldwide. And for our client, or sows that I've been involved with in looking at mycoplasma projects, it's about 720,000 sows, and we still got a ways to go. We're 91.2% there, so we're hoping to continue to work forward and get the rest of those cleaned up as well. So very similar to Cesar's numbers and Joel's numbers. I just wanted to put this slide in. We are at the Leman conference, and Carlos had certainly a big impact on me and the conference as well. And we're almost, Maria, almost 25 years ago, I went to Carlos's office, and I had a protocol on how we were going to try and eliminate mycoplasma from a herd. And I went through the entire protocol and asked Carlos what he thought, and Carlos said, well, you know it's not going to work. And I said, well, great. And Carlos said, but you absolutely have to try. We've got to learn how to do it, and we got to start. And so Carlos was a tremendous supporter and certainly helped along the way in the process. And by the way, that herd we did almost 25 years ago is still negative today. So fortunately, we were able to keep that one negative. Again, one of the advantages we've had in the U.S., as we started going down this path, it was already there on multi-site production, where we have fair to wean sites moving off to either nurseries or wean to finish sites, and certainly that's given us a real opportunity to move forward here. And I think it's important to go back and look at, especially for areas or producers that are starting down the path, is why did it become such a concern? When I first started practice, I would say that mycoplasma wasn't as big a concern. And so what we saw was in those early days is many people kept their own gilts out of their own production, and they were exposed at an early age. They came through the system, had good immunity, and we had low prevalence through the herds. Or they were developed in an off-site GDU, and they were positive, and they were well infected and well immune by the time they came back to our sow farms. But as the genetic companies made the push to make PRRS negative status pigs, they also cleaned up mycoplasma along the way, which was fortunate, just like Joel said. And we've done the same. As when we've cleaned up PRRS, we've been able to add on mycoplasma. And so we started getting a lot of negative animals coming into our herds at select weight. And this is kind of like the recipe for disaster. If we're bringing in animals at breeding age that are negative and trying to get them exposed, you just can't get them stabilized in time. And I'd had the opportunity to see SBF pigs. We had some producers that did some SBF work early on in my practice, and those pigs just didn't cough. You know, when I first started practice, everybody said, Tom, right, it's a dust cough. And what I found out was SBF pigs don't have dust cough, and there is no such thing as a dust cough. And so they grew very good, and the performance was great, and we wanted more of those pigs. Then Dr. Alexander started with the medicated early weaning, another method of making clean pigs. And through the 90s, We had the opportunity, because we had a lot of disease at that time. We had APP, we had swine dysentery, we had mange, we had lots of issues, and so it was very compelling to go, and poor genetics, and so it's very compelling to go ahead and do a depop repop on some of those lower health status herds. And we saw how those pigs performed, and mycoplasma was just one of those diseases that we were able to get rid of. And again, no cough, good growth, and low mortality. We wanted more of those pigs. So we said, how can we move forward? And it's like anything else, there's always a progression. And so first step is to try and prevent it and keep it out. And like Joel said, I believe it does happen that we get infection, but it's pretty rare. So I think that's one that we can win on. But once the herd breaks, we want to work towards controlling the outbreak, getting the herd stabilized, and then move forward into elimination. The quicker we can stabilize that herd, the better the performance will be on the wean to finish, because that's really where the most significant cost is once you get through the initial outbreak stage. And then move forward to an elimination phase once you've reached that herd stability. The fast track, of course, and particularly for a lot of the genetic suppliers, is to move on to depop repop right away. That resets the clock immediately. So what's the disease cost? It's easier in a large system than if you just have a single farm of your own to be able to compare flows and say, what are those negative herds doing? What are the positive herds doing? And taking a look at that economics really helps. We're able to go through a large database over a number of years and track that performance. And the yellow bars, sorry, they may not show up as well here today, but the yellow bars are just showing us mycoplasma only. The green bars are PRRS and myconegative, and the red bars are PRRS and mycopositive. So we know that's not a good combination. We can see that average daily gain's better, feed intake, feed efficiency, percent mortality, cost of medication, and feed grade medications are lower. And so again, those are the driving factors that took us to moving more herds to the negative status. And graduate student working on her master's at North Carolina State here a couple of years ago did some work looking at, we've always talked about that cost impact on the wean to finish side because we believe that's where most of it is. But surprisingly, there is a pretty good sized impact on the reproductive herd. And Lindsay's work went through and showed us what that really can be. That's 4/10 more of a pig weaned and less non-productive sow days. And again, when you plug those numbers into the model, it comes up pretty dramatic. And Cadence showed yesterday at the student presentation and won the award for adapting the model to allow people to plug in a few simple numbers. Again, it's just a simple spreadsheet to look at what that cost is. And we're looking here, and it's almost $1.90 when we look at just making those changes that Lindsay showed. So again, there's an impact on the sow herd that lots of times we never accounted for. And we did some work with that same database with Dr. Linares and Gustavo and some of the other, and Bob Morrison was involved with this project at that time still. And we went through and looked at it, and in that particular time frame, we came up with about a $5, and again, just on the wean to finish market, and this was looking at modeling a 5,000 sow. So again, if we looked at a herd closure, traditional herd closure, or if we looked at a medicated program, and I'll explain that a little bit later, we can see the costs or the time for payback is very short. And so again, that's been another motivating factor to get people to go along with doing that. And Cadence also, you can choose the wean to finish side, and here we're showing a cost of $3. And so again, what you want to do is use this model to help you get an idea where your performance is at. Use some of those guidelines there to plug in some numbers, and you can look at some different scenarios to help you make that decision if it's worthwhile going to. So again, when we talk, the stabilization is really important after the outbreak. For me, I really don't want to live here forever. Again, then we're talking about going into whether we're going to do a fast or a slow. Depop, repop is the ultimate fast, and then the herd closures or the medication programs are other opportunities to move forward. Under Dr. Peters, Dr. Roas showed us that when we're looking at trying to infect gilts and get those stabilized to come into a sow herd, effectively we can't get it done. It takes 6 gilts to 1 to get them infected. And Dr. Sponheim also did some nice research looking at the different mechanisms to expose animals. And historically, we used natural contact or cedar models. Again, the cedar models can be effective, and what Rojas's work said, it just takes a lot of cedars to get them positive in a short period of time. The intratracheal inoculation historically had been done for doing research work and a great way to get animals exposed. We decided in one of the eliminations we were going to do intratracheal inoculation, and after 1,250 gilts, and it was about 9 o'clock at night, I was crawling from gilt to gilt. I said, there's got to be a better way. And then we started doing the aerosol exposure. The aerosol exposure is simply getting lung homogenate and running it through a hurricane fogger. And again, that's what it looks like when you're doing the project. And the pigs like it a whole lot more than doing the intratracheal, and the people like it a whole lot more as well. So again, we found a good way to get that exposure. And one of the true lessons learned is making sure that you get good exposure as you start the project. Without good exposure, the projects are more likely to have issues. And I think that's one of the things we saw in some of our early failures, was that we weren't able to get good, consistent exposure. But once we started that, the success rates have continued to improve. So again, we want to make sure that we get to that stability. And if you take nothing away else from this talk, understanding this chart, and Dr. Peters and, Dr. Fano did a much nicer job than my crude bar napkin math here. And so, again, what we're showing is the pigs are born negative, and they're going to get exposed over time, or we bring in negative pigs, and they're going to get exposed over time. And what we want to do is we want to have a sow that's shedding that's immune and has cleared the mycoplasma and is shedding low numbers to her piglets. Not 0, but low numbers. And so, again, if we work the math backwards, what that tells us is we have to have those gilts exposed by 80 days. Not just being exposed, but they need to be completely exposed. The entire group needs to be exposed so that we can get to this final goal here. And so, again, changing what we thought initially and helping us to move down this path faster. So when we talk about the different methodologies of doing it, the depop, I wanted to put depop repopulation in here because it's still an important way to do it. Again, it's the very rapid reestablishment of health status, the fastest way you can get there. So if you're a multiplier and you want to get back to negative production, this is the fastest way to get there. It's the most expensive, but it's the fastest. And I would say nearly 100% effective. I used to say it's always effective, but somebody will always make you a liar. So again, it's very effective, and the site's empty and adequately cleaned is really the two big issues that you have to make sure that you execute. And we've done them with off-site breeding projects, and certainly that reduces the downtime and the cost. And again, what we use when we're doing the off-site breeding projects is 4 weeks pig to pig. Essentially, that's 6 weeks of production because you can't wean the pigs at day 0. And so that's what we use when we look at the numbers. When we get a chance to plan them ahead of time, we've actually, in this case, we actually increased the number we were breeding to make up for some of that hole that you get when you don't have pigs for those 6 weeks. And again, Cesar showed some of this already. Maria's work showing us the length of shedding. And as we started looking at doing the herd closures, this became a pivotal study that was done. And fortunately, we got lucky on the first one we did. Maria hadn't done the work yet, and we just got lucky that we went that long. And so she proved to us what the right time was. And so again, you're loading up and closing the herd and homogenizing that population. And one of the things that's always a challenge as I talk to producers with is we've got to have 8 months worth of gilts, and 2 months of those gilts haven't been born yet. So you have to load up with some older ones, and you have to figure out how to manage that inventory. And I can talk with you more later on how to do that, because there is some ways you can do that and get very good performance. Again, the 240 days is key. Vaccination, we've always included vaccination. The question is it necessary? We've done it we do the gilts twice coming into the herd. And what I've gone to more now is the quarterly until the project's completed. And again, we've had good success with that. Sometimes we will see a little bit. The animals that are bred 1 to 2 weeks will see a couple % drop in farrowing rates, so we'll adjust those breeding targets accordingly for those weeks we're going to give the injections. Again, washing and cleaning the environment, I'm not sure if it's necessary. We just done it. It's nice to have a clean gestation barn anyway. And so, again, we got the vaccination, and then we come with the medication. This is the way we've done historically. Most of them out at that 27 to 29 weeks. We start doing the piglets the same time. We inject those with products like Duraxin has been what we've used the most. And we've done that from 27 to 31. And then because we wanted belt and suspenders, then we came in with Denigard, or like a Denigard CTC or CTC in that same time frame in the feed, just to give us another layer of protection. The model that I've used more recently is once we've gone through and got the exposure done and confirmed the exposure, is we're doing a medicated treatment. We've done several different models, so a lot of different antibiotics work. This one's demonstrating Duraxin, going through doing 2-dose Duraxin. And then if we need to, coming back here at the end and retreating if we've tested the animals and we're not where we want to be on our testing. And so it's kind of a plan B, so to speak, within the plan A. But generally what we've been able to see is these pigs, just like the medication program, if we've done a good job of exposure, the pigs that are generated here by week 15 are staying negative through the finishing phase. And so you're picking up that added advantage, and essentially you're paying for the program before you're completed. So again, based on the economics. The whole herd medication is where we went through and did a mass medication 2 weeks apart to the entire herd. We started those programs using Duraxin and working through those, and then continuing to do the 4 weeks of pigs just like we did in the herd closure. And you can see here over the course of time, the herd closures have been the most successful. The medication and not doing a herd closure is about a 50-50, about a coin toss. But the closure, so I think there is some magic in the closure, but you can see the average of all the herds in the database, and that's herds from 2 years ago to 25 years ago, is averaging 8 years negative. And so, again, it's more of a dependent upon the amount of time from the closure. And so this is a study I did with Maria, and we looked at survival, and you can see here that the whole herd medication dropped off at about 8 months. But then once we got to that time frame, they stayed very good. The herd closures, we saw a little longer decay there, but again, better performance over time. And so both can be successful long term. And Maria has worked with Behringer and Amanda at Behringer to put together the roadmap for mycoplasma eradication. It's a tremendous resource for you to go and look at. A lot of scientific data is there for you to review if you've got questions, if you've got concerns. Certainly a good resource. The other thing that I would say as we went along was the diagnostics got a lot better. And we started out, we're using ELISA and working with ELISA, interpreting ELISA titers. And again, as we move forward, we had kind of some guidelines of where we thought it was vaccination and where we thought it was real field infection, and again, a little crude method. And then we started working with PCR. PCR came along. Again, the oral fluids. And, I remember when I was in veterinary school, Howard Hill said, positive results are meaningful, negative results make you feel good. And so, again, that's the problem with oral fluids, is we get a lot of false negatives, and so you feel good and you probably shouldn't. Then we went to nasal swabs and ended up at the tracheobronchial swabs, kind of being the gold standard today of what we're using for diagnostics. This is one we've done in the eliminations to see if we're getting good coverage through the barns, and surprisingly a relatively simple method to get a good diagnostic, and it can be useful in an outbreak situation too if you want a long-term diagnosis. It's collecting a sample over an extended period of time. Just a piece, it's really cheap. It's just a piece of aluminum foil. You do a Swiffer and you send it in for PCR. Again, positive results are meaningful, so be careful. Again, the next stage of diagnostics and some of Alyssa's work looking at sequencing and sequencing data. Again, as you move into these, in the beginning we didn't have it, and the question always was, did you really eliminate it, or did you get a new or different mycoplasma? And so by doing a sequence before you do the elimination, you can come back and answer that question if bad things happen and you need to compare it later. And so first thing I would do today is get a sequence so that I knew if I did have a re-exposure, what happened. The ASV put together a classification system that's out there for us so we can classify and standardize herds the same way. And we did a study because there's been a question over the years on people doing eliminations. Well, can we save money and just treat the P1s, because the P2s they're immune. They've been in a herd over 240 days. They shouldn't be shedding. And so could we get by with just treating the P1s? And so it's been a long-term debated question. And so we set up a study. We had a herd that did break back, and we were able to go back and look at that herd. And we went back and we set the clusters up where we had the negative gilts that had come into the herd that had been there since eradication, and then we tested all the animals around them to see what happened. And again, did tracheal swabs to do the testing for PCR. And what we found was that, yes, indeed, there were positive immune sows out there. And when we added the suspects in, 80% of those positive sows had a recirculation of mycoplasma. And when we looked at it, it was those animals that were closest to that new gilt that was breaking that was shedding back to those sows. So again, we can see that there is recirculation, and yes, it does pay to treat all the animals in the herd. Caesar talked a little bit about this data already, and again, like we said, I think the data speaks for itself. These are hog-dense areas, and we had 6% of the sites turn positive in very pig-dense regions. And when we went back and looked at the data, 3 of those sites, the caretakers were taking care of positive pigs as well as negative pigs, so it probably didn't surprise us. And the incidence is really probably closer to 3%, but we continued to report it as a 6 as we saw. Again, we still have to have good biosecurity, even though it's, I think, a rare event. And the filters always have the farm in the bubble as a filtered farm, along with all the other biosecurity things we need to do. And today, the biosecurity continues to evolve, and we continue to see more and better biosecurity methods, and using the geofences and having better technology to help us there will only help in the future as we go forward. And as we've already said, today at US SHIP, we have both PEDV and mycoplasma as programmed diseases within US SHIP, so hopefully that can continue to help us as an industry as more people will be joining those programs on a voluntary basis. So what happens once we've completed an elimination is you sit back and count the money, right? And so hopefully anyway. And so in summary, again, it's been an evolutionary process that we've learned a lot along the way. Again, we've got better tools today. We've got the aerosol exposure. I think that was our biggest headache up front, was how could we make sure that we had a good, accurate day 0? How could we make sure that all the animals had been exposed? We've got better diagnostic tools. We've got the PCR. We've got the sequencing so we can know if it was there before. But as I tell all the young vets, there's still some value in having ELISAs and using serology as well. So again, don't forget about that as a potential tool. And again, we did mycoplasma mainly because we could do it, and we could do it successfully. And we've been able to establish herds over a long period of time to stay negative, and I think that's been the biggest driver for more producers moving forward. And the biggest thing we've learned is that we're able, like Joel said, to piggyback it on top of PRRS breaks. You're closing the herd, and today, even longer for PRRS than what we did initially. Back in the good old days, we could do 210 days. We just only had to add 30 for MICO. Now we can get MICO done ahead of the PRRS. And so, again, it's a great opportunity to add that on at the end. The 240 days is probably the most important piece to make sure we're getting that time, allowing that immunity, allowing that clearance. We've used different medication programs. I don't think the medication's as important as some of the other factors, that immunity, getting that good solid exposure. So at the end of the day, it's still all about the pig performance. Not only the wean to finish, where that's certainly where we see it the easiest, but it also is telling us there's advantages on the south side as well. I believe it's a battle that can be won, and there'll be more methods in the future. I know this group out there, there's more creativity, and hopefully in the future we can talk about when we used to have mycoplasma in the industry. Are there any questions?
Any questions for Dr. Yeske?
So, Paul, I'm curious to know, from your clients, the ones who may still be positive, right? Is it because, has it been difficult to convince them? Has it been that the programs have failed? Or I tend to think, from what I hear in when I talk to certain practitioners, it's like some farms are the problem farms. Is that something that you have observed as well? Or, which ones are those positive ones?
Yeah, some of the farms that are still in that 8+%, they've got some unique issues, and they're doing some other projects, and so it's kind of gotten put on the back burner. They're still going to move forward to it. So I think if we get a little bit more time, we can get rid of those herds that are still positive out there. I wouldn't say that they're not believing. It's just not a good time for that herd at the current time. Yes.
How do you determine day zero to start the program? Do you test just 30 pigs, or do you have an ongoing testing to reach a certain percent of positives?
Yeah, it depends a little bit on are there multiple sites where the gilts are? Are they in one particular population? So there's a little bit of site dependent there. But I'm usually trying to do at least 60, and I want at least 75% of those to be positive. If not, I'm going to come back and test them again. And if we don't get that, we're going to go back and expose them again. So it's hard to get to 100%. That's what you'd like to have. Oh, yeah. But we've been able to do it generally. I would say some of the first ones we did with the fogging, we got 100%. But if you can get over 75, I'm pretty comfortable to go ahead and move on and say that was day zero.
Very good. Thank you.
Any other questions? Thanks very much, Paul.